All right, on this next example, what we're going to notice is that when we look for descending order, perfect descending order, we start at a high degree of 4, and then we go to 2. Well, if we're paying attention, we just skipped 3. It goes 4, 2. We need 3. We need the cubic term. So the first thing I'm going to do is write the polynomial down here, 2x to the 4, give it a gap, minus 15x squared, minus 16x, and then minus 4. So we got 4, blank, 2, 1, none. Well, we have to have perfect descending order, all my degrees present to win. So I fill in an x to the third. The way that we add that is we add a 0 to not change the problem, because we can always add a 0. So then off to the side, we are dividing by a linear, so this is good to go. I'm going to take my x plus 2, set it equal to 0, and then solve that, minus 2 from both sides. Solving for x, I get x equals negative 2. Now I put that in my little half box and bring all my coefficients down. So now that I have that extra missing term, I can be assured that I will be on the path to victory here with my coefficients of 2, then 0. Otherwise, I would have been messed up. Minus 15, and then minus negative 16, and then minus 4. And then I do the process. Everything after that is normal. It's just making sure that 0 is present to win. So bring down the 2, and then our algorithm says you take these numbers, multiply by the number in the box, put the result over here underneath the next coefficient, which should give me a negative 4, add with the 0, and I get negative 4. And then I multiply by the negative 2, and that negative 2 over there, and that gives me a positive 8. And then I add there, I should be getting a negative 7. And then I multiply the negative 7 by the negative 2 over here. And that should give me a positive 14. Then I add my 14 with my negative 16, and that should get me a negative 2. And finally, I multiply by the negative 2 at the front, and I get a positive 4. And it just so happens my remainder this time is going to be 0. This x plus 2 is a factor of this polynomial up on the top right there. And this is the only way I could have factored that polynomial, is using division. I could have used long division, but division. So we have x to the 4, and we divide it by a linear, which means my result needs to be x to the third here. So 1 degree down, I start filling these in. So x to the third, and then go down descending order by degree, x to the second, x to the first, and then x to the 0, and then my remainder. So my final answer should be 2x to the third minus 4x squared minus 7x minus 2. This is the result of division. Had I said, hey, factor this polynomial, 2x to the fourth minus 15x squared minus 16x minus 4, and I said, hey, go ahead and factor that. Well, the only way I would have done it would have been through division, and the factored form would be x plus 2 times our result of division. That would be the factored form for this polynomial. Now, I might further factor. I might, have to, but it doesn't look like it does right away. I'd have to do another process of a rational root theorem or something to keep going. Anyway, there we are for synthetic division.